Calculating power, work and time using this formula, then what I'll do is an example from each of these questions just to show you how it's done. So question 1, if we do part D of question 1, question 1 tells us that we have 1000 kilojoules of energy. So our energy is 1000 kilojoules. Well, that's thousands of joules. So that's 1 million joules. And part D says our time is 9 minutes and 30 seconds. So 9 minutes and 30 seconds in seconds, because we always want to have our time in seconds, would be 9 times 60 seconds plus 30. 9 times 60 is 540 plus 30 is 570 seconds. The formula then, power is work divided by time, or energy divided by time, remembering that work and energy are the same thing. Power then is our energy divided by our time, which is 1 million divided by 570, and 1 million divided by 570 is 1754. So 1754.39. So we could write that as 1.8 kilowatts to two significant figures. Question 2. We could do part D of that as well, why not? So question 2 tells us that our time is 3 minutes, and doing that in seconds, 180 seconds. And in part D we have an energy of 150 kilojoules, 150,000 joules. So our power is our energy divided by our time, which is 150,000 divided by 180, and 150,000 divided by 180 is 833. So 833, which we could write as 8.3 times 10 to the 2 watts, again to two significant figures. Question 3. We have a weightlifter lifting bricks at a building site. He's doing a set of 10 lifts, raising a load 50 kilograms by 40 centimeters. So we have 10 lifts, each of 40 centimeters, 0.40 meters. Because again, we want it in standard units, and centimeters are not standard units, but meters are. And the mass he is lifting is 50 kilograms. 50 kilograms times 10 because we take gravity to be 10. Weight is mass times gravity, remember. So there's 500 newtons. So again, if we do D, we want to know his power. Well, power is work divided by time, and work is the force times the distance. I should call that weight, or call that work, just to distinguish these W's from each other. In fact, I will just leave that as W. So force times distance is work divided by time. The force, of course, is the weight, so there's 500 newtons, times the distance, which is 0.4. And the time, well, we're told in D the time is 30 seconds. So we want to know the work done per second. We're going to divide by 30. So 500 times 0.4 divided by 30 gives us 6.7 watts, 6.66 watts. Question 4. We have electric kettle, 2,400 watts. So our power is 2,400 watts. And doing D again, how long will it take to the nearest second to supply water with 850 kilojoules? So our energy, 850,000 joules. You can see from these questions that the joule is a very small unit of energy. So power, of course, is energy divided by time, but we want the time here, so we have to make time the subject. So if you multiplied both sides of this by time to get rid of the time on the bottom line, you'd have power times time is energy over time times time, which would be energy times time divided by time, and they would cancel. So you'd have power times time equals energy. We want time, so we divide by power, and we get time is energy divided by power. So we have time is energy divided by power. Our energy was 850,000 joules, 850123, and our power was 2,400 watts. So 850,000 divided by 2,400 gives us 354 and some small fraction of a second, 354.16, but to the nearest second, the question tells us, so 354 seconds. And then question 5. These wattages are written on the labels of a selection of hairdryers. How much heat energy in kilojoules will each one produce every minute? Let's go with D. So question 5. And D again, we have 800 watts and we have a time of 60 seconds. We want to know the energy. We know that power is energy divided by time, and from our last question we might remember that we got energy was power times time. So we have 800 times 60. And 800 times 6 is got 8 times 6 is 48, 800 times 6 is 4800, 800 times 60 is 48,000. So it's 4.8 times 10 to the 3 joules. So there you have an example on each of these 5 questions. Questions 1 and 2 are very similar. 3, 4 and 5 are looking at different ways of arranging the formula in order to get the answer.